Alright, hello boys and girls. So today I will be starting my lecture series on machine learning, and this will be the introductory lecture in which I will be explaining what is machine learning, why machine learning, and how we do machine learning. So let's start. Now, what is machine learning? Machine learning, or ML, which it's abbreviated as, is a study of enabling machines to make some decisions or predictions based on some data that has been given. Now, what is this data? Okay, the machines, I'm pretty sure we all understand that the machines are our laptops and they make some decisions or predictions. And what is this data? Now, data is generally anything that contains some sort of information. So, from a human's perspective, data can be, let's say, an image, some text, some videos, all these things. So that is what machine learning is. Now, why do we even require machine learning? Why aren't the traditional methods, we can just be satisfied with them, right? Well, in many tasks, as it's inherent now, many of those tasks like facial recognition and being a chatbot, these things are just, they're tasks which require some sort of inherent intelligence. So in a chatbot, you can, let's say, you can find structures in English language by, okay, so if I have a window that is a chat window, I have provided some input queries, that is something that I have given to the chatbot to read and respond to. Now the chatbot can take this window and based on some structure it finds here, it can give a response. But is that intelligent? Is that even intelligent? Well, technically it's not. First of all, how is this why not choose this window, or why not choose a shorter window of words? So we need to actually even find how long the window should be and where exactly the window should be for these sort of things. Now that is something that varies with the sentence. It's totally dependent on the input. So that's why this sort of chatbot business requires some sort of inherent intelligence that comes very naturally to humans, but for machines who only see the world as zeros and ones, it may not come that naturally to them. And if you're trying to build an algorithm that takes up all these things and calculates what the next word should be or how the chatbot should respond, maybe the algorithm may not be that trivial. And similarly, facial recognition. Now, facial recognition is another one of those tasks which comes very easily to us humans, but if you're trying to write an algorithm to recognize faces, then that becomes actually very tedious. You have to find out what sort of structure the face has, any features the face has, then you have to process it and then match it with a database of faces. All these things are there. It's not that easy. This sort of task is, well, it requires another sort of intelligence only, which comes naturally to us humans but may not exactly come naturally to machines. And so the whole point is that this inherent requirement of intelligence is basically finding a pattern in the data. So in facial recognition, it's finding a pattern in the images that you provide, or prediction based on past data. So that's the case with the chatbot. So if you provide some 10-20 pages of text or documents to the chatbot, then it will obviously read the whole document, and based on whatever was written in that document, it will tailor the responses according to that. So it essentially predicts the next words or next sentences, that sort of thing. Now, the two main categories of machine learning problems, they fall into either estimation or generalization. Now, there are many more, but these are the two main ones. So let's discuss what estimation is. Estimation, for example, let's say you have a cubicle room, and in all the 8 corners of the room, you're placing a sensor. So this is the cubicle room. In all the 8 corners, I have placed some thermometers, temperature sensors, and with these 8 sensors, I want to find out what the temperature of the room is. Now, obviously, in real life, all these 8 sensors, they might give readings which are not exactly the same. They might be in and around each other, but they'll be they'll be differing by a small quantity. Now using that, can you figure out the actual temperature of the room? Now many might say, okay, let's take the average of the temperatures that is provided by each of the sensors. Yes, that's one way to go, but machine learning has proven itself to give better results in such cases. So in many cases where the sensors are linked to each other, something like that, then this average business will not work. Then in that case you have to start looking at much more clever ways to deal with this. And similarly, generalization. Now generalization is finding pattern in data and tailoring the responses according to that. So for example, suppose I have stock market data. It will look weird. Yeah, I mean, it won't look like that, but it will look something like this. Yeah, it will be a small fluctuations and all these things. Now based on that, will it be able to predict anything in the future, any stock prices in the future? So that sort of thing is generalization. And so generalization is basically capturing the pattern in the data and tailoring your responses according to that. Now that's the long intro on why machine learning. Now how machine learning? So machine learning is much more of a human oriented subject than it seems. So many people have the misconception that in machine learning everything will be given to the computer, things are fine. Yes, the computer will magically give you the answer. No, it's not like that. You are the one who has to frame the problem first. So the machine will just do what you tell it to do. Okay, so if you are giving it a task, you have to formulate the task mathematically, because mind you, a computer only understands zeros and ones. Okay, so you have to somehow manage to formulate the problem mathematically. So suppose I say, okay, I'll give you a database of faces now, and I'll give you a new photo. Now recognize the face from that. Okay, a human will understand what to do, but that won't be understood by a machine. Machine only works with zeros and ones. So in that case, you have to somehow find a mathematical formulation of this facial recognition problem. Okay, then next is you have to make some assumptions on data, that okay, the training data that I'm taking and the test data, that is the inputs or queries that the user will ask later on, that is not in the database, they'll be very similar. So the data that I'm training on and the data that I'm testing on, those two will be, let's say, sampled from the same distribution, they'll be correlated, something like that. So these sort of assumptions we have to make. Otherwise, what's even the point if the training data is not similar even to the test data? Then might as well just not even train the model, just tell it to give any garbage. Now the third thing is something called the evaluation criteria. So the evaluation criteria is kind of like the performance measure of the machine learning model. So the machine learning model, what it does is it will give you answers. Now how will you judge the quality of those answers? For all you know, it can be giving you trash, and we don't want that. We have to somehow find a performance measure that says, okay, this answer is trash, this answer is not trash. And that brings us to the next point, is modeling. So in the problem framing, you generally figure out what sort of input I'll be giving and what sort of output I'll be getting. And the assumptions will deal with the data, what sort of data you're getting. Evaluation criteria will generally test the quality of the output with the given data, if you have any. And modeling decides how the input is transformed into the output. So it's basically the model, as I say, it's basically a function that takes in some input from the input space and transforms it into an output from the output space. So that's what a model is, and modeling is basically figuring out how that function looks in mathematical form. Okay, so the next is the learning algorithm. So the learning algorithm is how your machine learns. So we call it machine learning, right? So obviously someone is learning something. So there is a learning algorithm as well here. And so these these criteria over here. In fact, the problem framing, assumptions, evaluation, and modeling, this is actually full on human. Now, this learning algorithm, that's where your machine actually starts working. So, this learning algorithm, it basically, from all the possible models, from all the possible transformations that you can make from the input to the output, it chooses the correct transformation. That's what the learning algorithm is about. It learns how to transform the input to the correct output. And it does so based on the evaluation criteria. Now, after all this, there is a sixth step called validation. Now, validation is basically testing it on unseen data points. So, testing your model on unseen data. So, if it does well on the training set, the training data, then obviously we have to check whether it does well in the other testing data as well, in real world scenarios generally. So this is basically a field test. That's what we call as validation. Okay, with that we can end this lecture. In the next lecture I'll start with some things called linear regression. We'll see what it is at the time. Until then, see you.